Hi everyone, happy to see you back here. Okay, so in this video we're going to look at 2.2, section 2.2 of your textbook, square root of a function. And it is in outcome R3. Alright, so what you see here is a sketch of the two graphs. You see y equals x plus 2, and you also see y equals the square root of x plus 2. So if you just look here, we're going to make some connections between x plus 2 and the square root of x plus 2. So in yellow, I'm going to highlight the one that's the square root version. All right. And what we're going to do is we're going to notice that there are a couple of points here, like right there and there. So that's the value where y is equal to 0 and y is equal to 1. If you notice here, these are points that they don't change from one graph to another. Now, look at the notes here. We've got the radical has no values when the original graph is negative. So if you notice down here, the line would have extended to continue on in the negative y values, but for the square root function, it does not have any values in the negative. It starts right when y equals 0. There are invariant points where y equals 0 and y equals 1, so that's what I just mentioned earlier, right there and there. And the values of y of the radical function are larger than the original function when y is in between 0 and 1. So I just want you to notice when you're drawing your sketches that you're going to have this little bump up here above the y equals 0 and y equals 1 point. Oh, excuse me. And if you notice right here, the y value is 4, and if you look directly below it, the y value is going to be 2. So that's if we have our that's if we have x equals 2. If we plug in a 2, 2 plus 2 is 4, square root of 4 is 2. So we end up with x equals 2, y equals 2 right there. Okay, so let's have a look at some important points of x plus 2 and compare it to the square root of x plus 2. So the x-intercept here of our linear is -2, 0. And the y-intercept of our x plus 2 is 0, 2. The domain of it is x is the element of the real numbers, or you can write it as -infinity to +infinity. And we'll talk about the invariant points in just a second. Those are points that don't change from one graph to another. And so here we're looking at the square root of x plus 2. Well, the x-intercept is going to be exactly the same. And the y-intercept is going to be the square root of 2. So it's when x is 0, we have the square root of 2. So that's comparing these 2 points right here. So the y-intercept is 2, and then this is going to be the square root of 2. So that's square root of 2 right there. All right. The domain of our square root function is going to be x is greater than or equal to -2. If I wanted to write it in interval notation so it matches this, I would write, if I wanted to write it in the interval notation so it matches this notation, I would write -2 is the smallest number, and it includes, and it goes to +infinity. All right. Now, the invariant points, if we just look at this note over here, it just kind of reminds us that the value for y is going to be 0, or the value for y, actually, and is going to be y equals 1. So that's where you're going to have your invariant points. So if we look at our graph, go back to our graph, let's look at this here. So when y is 0, what's my x value? That is -2. So that's -2, 0. And my other invariant point is right here, when y equals 1. Well, what's my x value? My x value is -1. whoops, negative 1. Okay, so then I can just write my answer down here. Okay, so this is where y equals 0 and y is equal to 1. A couple of points to sketch. These are steps to sketching when you're given a graph of the linear version of it. So let's say we're given y equals x and we want to graph the square root of x. So you want to cross out the part of the graph where the y values are negative. That would be anything below the x-axis. Place a point on the graph where y equals 0. So this is your starting point. And place another point where the graph is y equals 1. So basically you're going to just cross everything down here, and then you're going to plot a point here and here, and then you're going to get the values to curve nicely above those 2 points, and find your y-intercept and plot that, and then just continue on in a nice smooth curve. So it's going to resemble half of a parabola on its side. Okay, so let's have a look at some more examples. Okay, so here you're given both of the equations. Now I'm going to leave in black what is the original, and then I'm going to plot my point at y equals 0 and at y equals 1. I'm going to do the same thing on the other side as well, and then I'm going to make a curve above those between those 2 points and continue my half side of parabola on that side, and I have to do the same thing on this side. So over here between my y equals 0, y equals 1, smooth curve, and continue on like that. Now anything below here, below the x-axis, this is gone. This does not exist anymore. So it's not going to be a part of the graph that you draw for your answer for the square root of, for in this case, x squared minus 1. All right. So when you are looking for your invariant points, we're going to see that this is negative 1. Sorry, over here, this is negative 1 comma 0. This is 1 comma 0. This over here is going to be, this one we have to figure out a little bit, right? So let's set what our y value is. So we'll take this equation that we have here and we'll go 1 equals, because that's my y value there, 1 equals and square root of x squared minus 1. And we're going to solve for x. So what you need to do is you need to square both sides to get rid of the square root sign. You get 1 equals x squared minus 1. And then add 1 on both sides, so you get 2 equals x squared. And then the next step would be to square root both sides. Remember that we have positive and negative of every square root. So you have negative square root 2 and 1. One's positive and one's negative. Okay, so those are these invariant points right here and here. Okay. Now, the next example here, this is the original that's up here. That is 4 minus x squared. If you want, you can think of this as y equals negative x squared plus 4. Then you can see that it's an upside down parabola that's shifted up 4 units. All right. So plot your invariant points right here at y equals 0 and at y equals 1. And also another point you could plot your y-intercept. So see how this is a 4? Take the square root of it, it's 2, so that's going to be your other point. Now between 1 and 0, you always want to go slightly above the 2 points that you've got and continue on your nice curve. And over here on this side as well, between y equals 0 and 1, you want to go slightly above the original and then continue your curve. All right, so that's the portion that is y equals square root of 4 minus x squared. All right, Now the domain, oh, I forgot the domain in the question above. You know what? You can fill it in, bring it to class, we'll double check it. This one is x is an element of the reals, and now this, if you notice the domain of its square root, you go between -2 and 2. So, all right. And our invariant points here are at -2, 0. You've got +2, 0. Now what are these values here? What is this value that comes along right here and here? Well, we're going to take y equals 1 and figure it out. So set y equals to 1 and solve, I'm going to square root that. So square both sides, and 1 equals minus x squared plus 4, minus 4 on both sides, and I've got -3 or -3 equals -x squared. So divide both sides by -1, and we end up getting 3 equals x squared. Take the square root, plus minus, and we get, when y is equal to 1, our x values are positive and negative √3. So there's my positive and there's my negative. Okay, so that's right here. So this number would be √3, and this number over here would be negative √3. So that's like right there and there. Okay, now the next one we've got, or the last one for this page, is this is the original right here. So if you notice that you've got your vertex at 1, 3, that's this point right here. So we're going to do the same thing. So look on your graph for nice points that have easy square root numbers, like perfect squares. So for instance, 4 over here, drop it down to 2 because that's the square root. And then 3, well, this is going to be the square root of 3. Okay, so this along here, so that's like 1.7 around. And then you got those 3 points, connect them, and it's going to be a nice wide curve. And this never crosses the x-axis, so this, the square root of it is never going to cross the x-axis either. Now let's get the domain down. The domain is xer, and then the domain for the square root is also going to be xer. There are no invariant points, so there are no points that don't change from one to the other. All right, let's see. So let's just go through and just label a couple of these points just so you see what's happening. So this is 2, 4, and it becomes 2, 2. So really the y values are being square rooted, and you see that here as well. So 0, 4, and this becomes 0, 2. This is 1, 3, and down here it becomes 1, √3. All right, which is like 1.7. Okay. I'll just fill this one in at the top real quick. Oops. And you can talk about more about how to do that in class. Okay, so now here you're given the graphs of you're given these sketches, and you have to give the graph of the square root of each one. So what you're going to do for this is you're going to take the invariant points, and you're going to take any nice points, any perfect square root points, like this here is a 4. You're going to drop down that straight and make it a 2. This over here, when y equals 1 and y equals 0, we're going to go across, plot those points on my original graph, make a slightly higher than those numbers curve, and then connect it to the 2 and draw my half side parabola like that. Okay, so invariant points for this are going to be -4, 0, -3, 1, and I could just read those off the graph. Okay, so any points over here, I'm going to do exactly the same thing. Make sure you're watching the scale that you have. This is my 1, so I'm going to go over here, put a point at my y equals 0, y equals 1. Have a curve above the 0 and the 1, and let's see, are there any other nice points? Yeah, see here at this 4, drop it straight down to the 2, and then you could connect it through that line. Sorry, that point. We're going to do the same thing on here. So when y equals 4, I'm going to go straight down to 2, and then I'm going to draw it slightly curved above. It might be easier if you take your paper and turn it around, and then you can generally do a nicer curve. So all this stuff over here is gone. It doesn't exist anymore in my original graph. So I'm just going to wipe that out for the sake of showing you. So my invariant points are going to be here. So that's at, like, let's say 1.5, -1.5, and +1.5. Just reading off the graph here, and -2 and 1, and +2 and 1. So that's where I put these dots. Okay, and the last one on this page, which is going to be the last one for this video, you've got your 1, you've got your y equals 0. Make this 2, this is going to be the square root of 2, so the square root of 2 is kind of like 1.4-ish. So, let's see, kind of here. And let's get a nice curve between these two values and connect it. Whoops, connect it like that. And it's going to be under here actually. Notice how I went above a little bit? I shouldn't have gone above because this value here is 3. And if I drop that down, the square root of 3, that's going to be like 1.7. So I should erase this over here. So it's good to use pencil when you're doing math. And so this is going to be below this 2 line, okay? All right, so my invariant points for this is -2, 0, and 1, 0. Okay, so I hope that went okay, and I'll do some more examples on the next video. Have fun doing homework.